Hi and Assalamualaikum. So we are from Group 5 and we are gonna present for the question 1. So here is my teammate. First Nur Azwatul Nadira and Nur Aimi Shaira and myself Nur Faiza binti Abdul Rashid. So this is our content in our lab 3. So I'm gonna read for the question. The question is the connection of two push button, which is switch 3 and switch 4. An external LED display and one buzzer are shown in figure 1. Write and execute a C++ program using Arduino IDE for the Raspberry Pi 2350 Basel Maker Pi Pico microcontroller that will operate the following patterns. A. Switch 3 is pressed, or LED is blinking in 1 second and buzzer on for 2 seconds. B. Switch 4 is pressed, even LED on in 2 seconds and buzzer on for 4 seconds. C. Both switch 3 and switch 4 are pressed, all LED blinking in 0.1 second and buzzer on for 3 second delay. So this is our connection. The figure show connection of two push button, switch 3 and switch 4, 8 LED and 1 piezo buzzer to the Raspberry Pi microcontroller.
For this project, we have one main objective and two secondary objectives. The first main objective is to develop a C++ input and output control program using the Arduino IDE for the RP2350 base maker PI Pico microcontroller. This allows the microcontroller to receive user inputs and generate the appropriate output. Second main objective is to integrate a hardware components such as a push button, buzzers, LED, and a piezo buzzer with the microcontroller. By connecting this device, we can create an interactive system that responds to user action. Second objective is to implement different LED and buzzer pattern based on the input received from the push button. Each button pressed will trigger a specific response, demonstrating the functionality of the input-output control system. The secondary objective is to verify the timing delay of LED, blinking, and buzzer activations using stopwatch measurement. This helps ensure that the program delay match the actual system perform and confirm the accuracy of the program. Overall, this objective helps us to understand the fundamental of microcontroller programming, hardware interfacing, and timing control in embedded system.
Hi, my name is Aimi. Alright, now we're moving on to the software logic. Let's break down how the system actually thinks by looking at this flowchart. The program follows a very straightforward but highly responsive loop. The moment you power up the board, it's entered the initialization phase. This is where the RP2350 configure which pin are doing what. So it set our 8 LED and the buzzer as an output and configure which switch 3 and switch 4 as a digital input with internal pull-out. So once that's out of the way, the microcontroller enter a continuous pulling loop. It constantly monitoring the logic state of the both switches, looking for changes. So here we implement 3 main condition branch. If the system detect that only switch 3 is pressed, it immediately run a pattern A, which blink the odd number LED and sound the buzzer for 2 seconds. If only switch 4 is pressed, it jump to the pattern B instead, flashing the even LED and keeping the buzzer active for 4 seconds. But if someone press both, like switch 3 and switch 4 is pressed at the exact same time, the logic override everything else to trigger a rapid emergency stop, flashing all 8 LED with a super fast 0.1 second delay. Of course, if no one is pressing anything, the system doesn't do anything crazy. It's just keep looping smoothly, waiting for the next input.
Pin 20 map as switch 3, which is switch or push button 3. Define switch for 21. For GPIO pin 21 map as switch 4, which is switch or push button 4. Define buzzer 18. GPIO pin 18 map as buzzer. Next, integer LED 8. 0, 1, 2, 3, 4, 5, 6, 7. This integer array named LED store 8 digital pin number which is from pin 0 to pin 7. Next, for integer I0, I less than 8, I plus plus. A for loop is to write clean and efficient code The loop runs 8 times from I0 to I7. The pin mode configures each LED pin as an output. Digital write LED I low. Then the digital write to ensure all LED are turned off when the system starts. Next, pin mode buzzer output. This is for configure the buzzer pin, which is pin 18, as an output. Then pin mode switch 3 input, pin mode switch 4 input. So this is for configure switch 3 and switch 4 as an input to read the button press. When the button are not pressed is high, which is 1, and when the button press is low, 0. Next, bool switch 3 state, digital read switch 3, bool switch 4 state, digital read switch 4. This value, high or low, store in boolean variable name switch 3 state and switch 4 state. Next, for the condition switch 3 and switch 4 press. If switch 3 state low and switch 4 state low. So that's mean the end logical operator check if both switch 3 and switch 4 are low. So that's mean both buttons are pressed at the same time. Next, digital write buzzer high. So if this condition is met, the buzzer is immediately turned high, which is on. For integer I, 0, I less than 15, I plus plus. For integer j, 0, j less than 8, j plus plus. That's mean for loops repeats the blinking 50 times inside it. So the loop turns all 8 LED on for 0.1 second. Lastly, digital write buzzer low. The buzzer will turn off after 3 seconds. Next is for switch 3 press. Else if switch 3 state low. So if condition C is false, the system evaluate this else if. Digital write buzzer high. If only switch 3 is pressed, the buzzer turns on. Then digital write 1 high, 3 high, 5 high, 7 high. That means the odd number LED, which is pin 1, 3, 5, 7, are hard-coded to turn on and blinking for 1 second. Then digital write 1 low, 3 low, 5 low, 7 low. And the odd number LED will turn off. And then digital write buzzer low. Then the buzzer will turn off in 2 seconds. Next, for switch 4 press. Else if switch 4 state low. If condition C and A both false, the system check if only switch 4 is pressed, then the buzzer turns on, which is digital write buzzer high. Digital write 0, high, 2, 4, 6. The even number LED, which is 0, pin 0, 2, 4, 6, turn on for 2 seconds and no blinking, and the LED will turn off after that, which is digital write 0, low, 2 low, 4 low, 6 low. Digital write buzzer low. Then the buzzer will continue sounding for 2 seconds and off when 4 seconds. That's all. Thank you from me.
Go to the next slide for demonstration. So I will show you guys which is on the question 1E, which is switch 3 is pressed, all LED is blinking in 1 second and buzzer on for 2 seconds. Here I will show you guys how it be working. This show the part B, which is switch 4 is pressed, even LEDs on in 2 seconds and the buzzer on the 4 second. Here I will show you guys the demonstration. So this is the last part of question 1C, where is the question B asked, which is both switch 3 and switch 4 are pressed, all LED blinking in 0.1 second and buzzer on for 3 second delay. So here is the last demonstration that I will show you guys.
Now, I move on the discussion part of our project. From the result obtained, we can see that the RP2350 Maker PI Pico was successfully programmed using Arduino IDE. The microcontroller was be able to receive input from the push button and respond by controlling the LED and buzzer according to the program instruction. For the first condition, When switch 3 was pressed, the odd number LED started blinking with a delay about 1 second. At the same time, buzzer was active for 2 seconds. This showed that the microcontroller could correctly detect the button press and execute the SI output sequences. For the second condition, when switch 4 is pressed, the even number LED is turned on and the buzzer remain active for 4 seconds. The output match the program requirement, indications that the input and output control work as expected. The most interesting part was when the both switch 3 and 4 was pressed together. In this situation, all the blink LED is blinking rapidly with a very short delay of 0.1 second, creating a flashing effect. The buzzer was also active for approximately 3 seconds. This demonstrates that the microcontroller could handle multiple inputs simultaneously and perform a different output pattern based on the condition. Overall, the experiment was successful because all the output behaved according to the programming logic. The LED and buzzer respond correctly for each button combination, proving that the input-output control system was functioning properly.
To wrap things up, let's look what we have achieved with this project. First of all, on the hardware side, everything worked out perfectly. The physical interface is solid, and we proved that the push button can reliably control an integrated peripheral array of 8 independent LED and buzzer without any signal issue. From programming perspective, the project successfully hit all its goals. We managed to put core embedded C++ concept into a practice using the Arduino IDE framework, especially when it's come to handling conditional if-else statement, internal pull-ups, and precise timing interval. So finally, when we test the system manually using a stopwatch, the real-world hardware response perfectly match our code. The delay timing, especially that rapid 0.1 second stroke effect, we incredibly sharp and accurate. So overall, the RP2350 platform proved to be a really stable and powerful chip for this kind of real-time I/O application that pretty much sum up our project. So thank you so much for listening.